This is a short video on how to read a four-beam balance. And what we've done in a four-beam balance is we have the largest mass on the back, then the next smallest, then the next smallest, and the very teeny tiniest. So when we read this thing, we've actually got either 0, 100, or 200 on this back slider. And here we go in increments of 10. So it's 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And then the next one down is in ones. So we have anywhere from 1 to 10 here. And then this guy is our last guy. And this one gives us actually 3 decimals. The only thing that's printed is the 0.1, 0.2 up to 1.0. And then we have these lines, like you see here, and these lines represent 1/100th. This is a tenth, and so these lines would each be 1/100th. And the last digit, the thousandths, are the distance between the two printed lines. Okay, so right here we would read from a thousandth, 1/1000th, up to 9 10,000ths, and 9 1,000ths, not 10,000ths, and then we get up to 0.3. So this is 0.2, this is 0.21, 0.22, 0.23, 24, 25, 26, and so on. So now what happens in here is we're getting the tenths. Tenths of 100th, which is 1,000ths. And we have to just guess on this one. So if this slider isn't directly on the line like we see here, we have to go between the lines guessing. And let's blow this up a little bit. And before we go to blow it up a little bit, let's look right here at these numbers and let's make sure we understand what this means. We can deal with hundreds. The hundreds are what we had up here, tens, which we had here, and then ones, which we have here, 1/10th, which is what the printed numbers are on this line, then the hundredths, which are the lines between the printed numbers, and then the thousandths, oops, didn't mean to move that, then the thousandths, which are this guy right here, 1/1000ths, and that's between here and here in each of these printed lines. So let's go to the next screen and look what happens. We have the same thing, only it's blown up. What I've blown up is the section in this yellow box. I hope that's yellow. As many of you know, I'm partially colorblind. This represents the slider, and the slider gets moved along here to make the final determination and give us the most accuracy. Now, if we had these little lines between the printed lines, which are the 2 and the 1, 3, 4, 6, and so on. If we had this guy between the printed lines, it would be much easier, and our accuracy, the scale would go way up. But we just can't really determine them that well, so we have to guess. So if this guy's sitting here, I'm going to guess either, well, let's see, it would be 0.3, 1, here, 0.3, 1, and then I'm going to guess this is a 3. But you see, if I'm over here, I'm really guessing. Okay, so now what would I guess this as? Well, this guy, I would guess, I would know for sure that it was 0.32, and it's between the 2 and the 3. So the 0.32 is going to be written like that. And now, what are we guessing? Well, I'd say halfway is about here. So it's less than half. And so I would just guess this at a 4. And so my last digit would be a 4. So the guess digit is what we're worried about, and that's the one that gives us the most accuracy, or actually another 1/1000th of a guess. So these guys we know for sure. This guy we know for sure. But when we're talking between the lines, we're guessing. And that's what it's all about. So if I went here, I could guess this as 0.3 and then 3, so it's 0.33 now, and this I would guess as a 1 or a 2. Your guess is as good as mine. But the guess is the last digit and gives us a little bit more accuracy. Thank you for watching. I hope this helped.